Hello, welcome to the first lesson on solving center of mass position of objects. Okay, so in this video I will take you through how to solve the center of mass of objects in Cartesian plane. Okay, so if this is your first time of you watching a video on my channel, or if you're a fan of my channel and if you've not subscribed to my channel yet, kindly subscribe for more videos. Okay, so let's start. Now the question is, find the center of mass position of a rectangular plate of density lambda being equal to x squared plus y squared minus xy of the size. Okay, so how do you go about it and how do you solve such questions? Okay, so what we will do is that I'll first write the center of mass formula, and that is called RCM, and RCM is equal to x bar y bar. Okay, where our x bar is actually the weighted mean. Okay, and that is summation mass x over summation mass. Okay, and y bar is equal to summation mass y over summation mass. If this will only hold if you are dealing with discrete points. Okay, but looking at this, we've been given a function, there are no discrete points in this, so this formula wouldn't work. Okay, but I just wanted to show you if we were given discrete points, as in x equals, or let's say lambda xy is equal to something I, or let's say something comma something. That means you know this is the x coordinate, this is the y coordinate, but now it is given in function of x and y, so you can't use that. All right, then it means that we'll continue with this. X bar will be equal to the integral of mx over integral of m for continuous function like the question we have here, and then y bar will also be equal to the integral of my or ym, anyhow you call it, then over integral of m, the same thing. Okay, so now let's quickly clean everything and then use the continuous formula. Okay, so now before we write the continuous formula, let's look at something. Okay, we are saying that center of mass deals with mass. Okay, so it means our x bar, like we said, should be equal to, let me write it first. Okay, x times mass, okay, over the integral of mass, and then y bar should be equal to integral of y times mass, okay, over integral of mass. The mass, they are small m's. Okay, I just made a mistake in the capital M. So what you do is you try and go and find your mass, but you've been given the density of the rectangular plate, of which you know that density, which is a lambda, is equal to, in continuous form it becomes a small change over a small a. Okay, so changing this over that. The reason is, you see, for density, all that we know is mass over volume. Okay, and what do we mean by volume? Volume is the space occupied by something. Okay, so if I put a 2D something on a plate, or if I put a rectangular thing on a surface which is a 2D, we just cover an area, it wouldn't cover the 3D. Okay, so in that sense, the space occupied by the rectangular plane or plate will be an area, and that becomes a volume. Okay, it's not necessarily that every time volume is supposed to be in 3D or cubic and cubic meter or cubic centimeter or something like. No, it's just that find the medium or the space occupied by the object you are talking about, and this time the space occupied is what? Area. Okay, so now lambda is the same as dm over dx dy in terms of, you know, small change in area, because here we are calling the size of the rectangular plate to be x and y, and then if you are talking about a small change, then it becomes a small change in the x times a small change in the y. Okay, now our dm will be equal to what, how do I put this? This will be equal to lambda dx dy. So if I want my m will be the integral of lambda dx dy. Okay, so I can come and put my m inside my equation, and when I put the m in, you see we have one integral sign, we have another integral sign, so when it comes, you will get two integral signs. Okay, So putting our m in, we'll get double integral of x, then lambda dx dy, lambda dx dy, lambda dx dy, okay, lambda dx dy. So this is how we'll get our question to be, or our new y bar and x bar to be. Okay, so let me clean everything and write it clearly for you. Alright, so these are our formulas that we have here. Okay, so now let's quickly do for the mass, which is a double integral lambda dx dy. Okay, this will be equal to double integral. Now from the y coordinates, let's call this one the y side and this one the x side. So it means that it will run from 0 to 12. The small changes in y, and the x will run from 0 to 10. The lambda is what? S squared plus y squared minus 2x, sorry, minus xy rather. Okay, y squared here minus xy and all the x dy. Okay, so first integrate it with respect to what? X, and that will give us, integrating the whole of this with respect to x, we get 1 over 3 s cubed plus y squared x, okay, minus 1 over 2 s squared y, then from 0 to what? 10 dy. Okay, and this will give us integral of 0 to 12. Then when you put x equals 10 in and subtract x equals 0, putting it in. When you put 0 in, everything will be 0, so we just have to put 10 in, and that will be 1 over 3 times s cubed, which is 1000. Okay, and that will give us 1000. This will give us 1000, sorry, this will give us 1000 over 3 plus 10 y squared minus, putting 10 then in s squared, it becomes 100 over 2, which will be 50y. Okay, dy. So now you are left to integrate this. Okay, now integrating everything would actually give us 1000 over 3y and plus 10 over 3, okay, y cubed minus 50 over 2 y squared from 0 to 12. Okay, and this will give us what? So I have 1000 over 3 times 12, okay, plus 10 over 3 times what? 12 cube, okay, minus 50 over 2, and that will give us what? 25. So 25 times 12 squared, okay, and that is equal to 6160. Okay, if the integral that we performed or we calculated for is correct here, then we should get 6160. So let's clean everything at the bottom of this y bar and s bar and put 6160 there. Okay, so that we know that lambda, sorry, double integral of lambda dx dy is actually 6160, and that is our total mass. Okay, so let's put our total mass here, which is 6160. Okay, so now let's integrate the numerator of the x bar. Okay, Now the numerator of the x bar is giving us double integral of x into lambda, which is what? S squared plus y squared minus xy dx dy. Okay, and now the whole of this will give us double integral x. Y is running from 0 to 12, x is running from 0 to 10. Then we have s cubed, okay, plus xy squared, okay, minus s squared y, then dy dx dy. Okay, now let's integrate this. Let's try to integrate this, and we'll get integral 0 to 12. Okay, first integral will be with respect to x, and here we'll get 1 over 4 x to the power 4 plus 1 over 2 x2 y square minus 1 over 3 s cubed y from 0 to 10, right? Then dy, and this will give you integral from 0 to 12 of 1 over 4 then 10 to the power 4. Okay, 1 over 4 times 10 to the power 4, and that will be so if you punch it on your calculator, the first term will give you 2500, okay, plus half of 10 squared, and that will be what? 25, because 10 squared, sorry, half of 10 squared, and that will be squared is what? 50. Then y squared, okay, minus 1/3 10 cube, and that will be what? 1000 over 3 y all dy. Okay, so when you integrate this with respect to y, we'll get 2500 y, then plus 50 over 3 y cube minus 1000 over 6, because it become y squared over 2, and times that will give us 1000 over 6 y squared. Okay, from 0 to what? 12. Now if I put my values in, I'll get 2500 times 12, okay, 2500 times 12, then plus 50 over 3 times 12 cube, okay, minus 1000 over 6 times 12 squared. Okay, and that is giving us 34800. Okay, so if our calculations, everything was correct, this is what we are supposed to get. Okay, if it is correct. Alright, so let's clean the numerator of the x bar and put what we got in here. Okay, so now the only thing left for us to do here is the numerator of the y bar. Okay, and that is giving us integral of double integral of y. Lambda is what? S squared plus y squared minus xy dx dy. Okay, and this will give us integral from 0 to 12, integral from 0 to 10. Then we have s squared y plus y cubed minus xy squared dx dy. Okay, so first we integrate with respect to what? X, and we'll get 1 over 3 s cubed y plus, so plus x y cubed minus 1 over 2 s squared y squared from 0 to 10 dy. So this will give you integral of 0 to 12 of what? Putting 10 in, we'll get 1000 over 3y plus, we'll get this side to be what, 10y cubed minus 50, okay, 50y squared, or dy, okay. The 50y squared, I hope you understand, it's just the s squared. When you put 10 there will be 100, and times half is 50, okay. So this integral will give us 1000 over 6 y squared plus 10 over 4 y to the power 4 minus 50 over 3 y cubed, okay, and from 0 to 12, okay, and this will give us 1000 over 6 times 12 squared, okay. So use your calculator and times 12 squared plus 10 over 4 times 12 to the power 4, 12 to the power 4, right? Then minus 50 over 3 times 12 cube, okay, and this is equal to 47,040. If all that we did here is right, because we can make mistakes, okay, but I'm hoping that we didn't make any mistake, okay. Then it means we have to come and erase the numerator of the y bar and put 470.40 there, okay. So y bar is equal to 47,040, okay. So simply put our RCM, that is what they've asked us to do, is simply equal to x bar is what, 34800 over 6160, comma 47040 over 6160, okay. Now this is the same as RCM is equal to 34800 divided by 6160, okay, and that is 435 over 77, comma, then 47,040 divided by 6160, and that is 84 over 11, okay, 84 over 11. So if only our calculations were right, then this is the solution to the question there, okay. Alright, so let's quickly look at a different question and we'll be done for this section, okay. Alright, so this question is saying that determine the center of mass position of a rod with density lambda equals that and length 10 centimeters, okay. So here I just dealing with one dimension, so our RCM will simply be equal to x bar, okay. Now here, since we are dealing with continuous functions, the x bar will be integral of x dx or something like that, okay. Y will it be x dx over integral of, well, let me write it well, okay. This is supposed to be m here, there's supposed to be m, so the mass should be there, xm, then integral of m, okay. Now let's look at something. We are saying that density is equal to mass over volume, okay. So the small mass over the small length. Why are we saying this? This is because we are saying this because looking at this, the space occupied by the rod will be just one line. Okay, so that will be the volume, like I defined in the first question. You said density is the mass per unit volume, and volume is the space occupied by an object. Okay, so object we are talking about is a rod, and the rod can only occupy a length. Okay, when you put a rod, just imagine putting a rod on a surface. Okay, the rod will only occupy a length. That's why we are saying that the space occupied will be what, in terms of just a length, that is dx. Okay, so our dm will actually be equal to lambda dx. Okay, so our m here will simply be integral of lambda dx. Okay, so here, since we are dealing with only one dimension, that there's not going to be any double integral. Okay, so our s bar will actually be equal to integral of x, and our m is what, lambda dx over integral of lambda dx. Okay, so with this, integral of lambda dx will actually simply be equal to integral of 2s squared, lambda is 2s squared minus x dx. Now, where will the limit be running to? The length given to us is what, in centimeters, is 10. Okay, so it means the rod will start from 0 to what, 10, and this will actually give us 2 over 3 s cubed minus 1 over 2 s squared, then it will be 0 to 10. Okay, so this is equal to, putting 0 in will turn everything to 0, so simply put 2 over 3 10 cubed, which is 1000, minus 1 over 2 10 squared, which is what, 100. Okay, so use your calculator and point this quickly, and get 2 over 3 times 1000 minus half of 100, which is 50, and that would actually give us 1850 over 3, provided what we said is true, or what we've done here is true. Okay, so when check the integral very well, because we can make mistakes in it. Okay, alright, our total mass, which is the integral of lambda dx, is giving us 1850 over 3. Okay, now integral of x lambda dx will simply be equal to, now the limit is from 0 to 10. Okay, then x into 2s squared minus x dx. Okay, so simply we get integral of 0 to 10, then 2s cubed minus s squared dx. Okay, so this will give us 2 over 4, which is 1 over 2. Let me write it. So 2 over 4 will be what, 1 over 2 s to the power 4 minus 1 over 3 s to the power 3 from 0 to 10. Okay, so if I put 10 inside, I would like it, so 0.5, that is half times 10 to the power 4 minus 1 over 3 minus 1 over 3, I'm using my calculator, so times 10 cube. Okay, and this is equal to what, this whole thing is equal to 1400 over 3. Okay, so I hope you understood it. Now our x bar is actually equal to what, 14,000 over 3 all over 1850 over 3, and now the denominators will cancel each other. Okay, and we get something like 14,000 over 1850, and so 14 over 1850 we'll get something like 280 over 37. Okay, so now our RCM center of mass position will simply be given by just the one dimension, that is S bar. Okay, but in some books they will prefer to write it in 3D, where they will tell you that RCM is simply the X bar is for 280 over 37, 0, 0, since you don't have the other coordinates. Okay, so that is it for the center of mass position of an object. Okay, so in our next video we'll talk about find the center of mass position of an object in a polar coordinate.